Hey, brothers and sisters, and whoever else listening. What we will learn today is it will be our first spatial analysis lesson. We're going to learn about heat maps and density map. So, why do we need heat maps? Yeah. So, a heat map is like a weather map, and we're gonna use colors to show where things are most intense. Yeah, where is the most concentration on this map. So we are using a data set which is a New York City motor vehicle accident, and we're going to use colors to describe where is the most accidents occurring. So for that, we'll go to we are continuing from the previous video, and I have only just changed the map view to street. Maybe you should go watch the previous video. Yeah, so let's go to the symbology thing and go back a bit and choose our primary symbology as heat map. Let's wait a bit for my computer to process. Yeah, so this is the heat map. As you can see, the denser color as are yellow, and the less dense color are blue. So you can see that here not much accident is has occurred, but these two spots there are likely to be more accident. So we can always play around with the colors as you wish. And for the radius part, the lesser amount of radius you choose, it will grab more heat with the less amount of incident, if that makes sense. If I give it 20, you'll see the hotspot will increase a bit. It's supposed to increase. Maybe it did. Yeah. So this is heat map. And now we'll see density map. What density map does is it calculates the number of incident for a specific region for a unit area. So if we for density density calculation, we'll have to use a geoprocessing tool. We go to view geoprocessing. Then for density we can use two spatial analysis tool. First one is point density, and input feature. For our input feature, we'll choose this one, and just nothing. And this area unit, you can say, as I've told you, that it calculates the number of incident per area, per unit area. So you can choose anything you like from as your unit, and then run. If you're working with like a vast amount of uh, a vast place, what is it called, a larger place, then use maybe larger unit area. Or if you work with smaller place, use less, I think. So this is, yeah, this is let's turn this off. And this is my density area. uh, yeah, point density. As you can see, they will all give the same result, because the purpose of all three, which I will show the next one later in a bit, to find the where the most incident has occurred, As you can see, like these two places, they will always give the darker shade. Yeah, so and we can do the same thing with another processing tool, which is kernel density. Same, run. What different in kernel density is that it will give you a smoother transition. Let's I'll show you. Let's, yeah, as you can see, like the transition is a very continuous. Then the this is our point density map, and this is kernel density. As you can see, that the transition is very smooth and continuous. So yeah, I think this is it of the special analysis. We watched heat density, sorry, not heat density, heat map, and kernel point density map and kernel density. They all serve the same purpose, kinda.